Hello everybody, in this lecture we will be solving 2012 IMO problem number 1. Here is a view of this problem as well as a simple sketch. We're given a triangle ABC with incenter I and AX center J. Recall that J should lie on the ray AI, the angle bisector of triangle of angle BAC. In addition, we are told that the X circle meets the three sides of our triangle M at points M, K, and L. Finally, we are to connect LM and BJ, like here, and we let them intersect at a point F. Similarly, we connect KM and JC, and they intersect at point G. And lastly, connecting AF and let it intersect BC at the point S, as well as connecting AG, let it intersect BC at the point T. We are to show that SM is equal to MT. So, namely that M is actually the midpoint of ST. Okay, so let's start with a few observations. This problem has the configuration of the in-center-X-center lemma. I assume you guys are all familiar with that. If not, please refer to my playlist about the in-center X-center lemma and the typical configurations. For example, if I connect BI, obviously this is an angle bisector. As a result, this would be B over 2. This angle is also B over 2. Recall that this would be an external angle bisector, so that would be 90 minus B over 2 here, as well as 90 minus B over 2 on this one as well. It's no surprise that angle IBJ is 90 degrees, and as a result IBJ and C are concyclic. And one more thing before I go further, obviously angle IBJ is 90 degrees, as I suggested. But anyhow, I would like to make a few more observations. For instance, if I connect the points K and J, obviously this is a tangent, so this is 90 degrees here. Let's also connect these two as well, J and L as well. So it's clear that A, K, J and L are cyclic. A, K, J, L is cyclic because angle AKJ equals 90 degrees, as is angle ALJ. Okay, so this is 90 degrees. So therefore this quadrilateral is cyclic. I claim that F and G are also on that circle, and to prove that, recall that this is also 90 degrees, obviously, right? And so therefore angle FBM is equal to 90 degrees plus angle B over 2. In a similar way, it's not difficult to calculate this angle over here, which I claim is, because this whole angle is angle C, the rest is 180 minus C, so therefore this is 90 minus C over 2 here, 90 minus C over 2. Recall that MC is equal to CL because of equal tangents, so MC equals CL implies that triangle MCL is isosceles triangle, and as a result we have an angle bisector on an isosceles triangle. That would be a 90 degree angle here, suggesting that angle CML is simply equal to just C over 2, right? So that's C over 2, C over 2. And of course this is a vertical angle with BMF, angle BMF. As a result, this is also C over 2. So this is C over 2 as well. Sorry for that. Now finally, focusing on triangle FBM, let me move a little bit down. So triangle FBM, it's clear that angle BFM is simply equal to 180 degrees minus the other two angles, which are namely, we decided FBM is 90 plus beta over 2, 90 plus beta over 2, minus, and this one is C over 2. Finally, this gives us 180 minus 90 is just 90 minus b over 2 minus c over 2. If we group them together, that's b plus c, which is 90 minus half of, we can replace b plus c with 180 minus a. And lastly, that would give us, so the 90 and the 180 minus, this will cancel out over 2, so we will have a over 2. Boom. So that's really nice. So this angle is a over 2, but notice that this angle is also a over 2. So as a result, this implies that, and knowing that a, k, j, and l are on a circle, f must also be on that circle because it subtends the same arc as this one, j, a, l, and they both measure a over 2. So that's perfect. So f is on that circle, and by a similar reasoning, you can also simply prove that this angle is also a over 2, namely mg, or I should say kg, j is also a over 2. So we have this very nice cyclic quadrilateral with those 6 points. Because it's on that circle, obviously this would be 90 degrees, because recall that AJ is the diameter, and as well this is also 90 degrees. Next, we observe that FB is just an external angle bisector, as we already pointed out, so these two angles are equivalent. But notice that BM is equal to BK, so these line segments are equal, and you have an isosceles triangle here. SBA is isosceles because you have an angle bisector and a 90 degree here, an altitude, so that only happens if these two are equal. So what I'm trying to say is, as a result, that the length SM is simply equal to, we can replace it with, well, at least SM is equal to SB plus BM, and replace SB with AB, AB plus BM, and replace BM with BK, I should say, AB plus BK, but that's simply AK. In a similar way, this angle here is C, this angle here, I should say an angle bisector, so you can easily calculate it. It's 180 minus C all divided by 2, which is 90 minus C over 2 here, and this is 90 minus C over 2 as well. And it is an angle bisector, but this is also an altitude, suggesting that this AC is equal to CT, right? And in a similar way, CM by equal tangents, maybe I should use a different decoration, is equal to CL as well. So by the same token, I should be able to express a TM in the following way. TM is simply equal to TC plus CM. Replace TC with AC and replace CM with CL. But that simply implies TM is simply equal to AL. Now finally, we just observed that AK and AL are equal tangents, and as such they must be equal quantities, and that finalizes the proof, because that implies as well that SM is simply equal to TM, making M the midpoint of ST. I hope you enjoyed this video, and looking forward to see you guys in our next lecture.